Laptop performance is better than it has ever been, but actually buying one has never been more confusing. Buying a laptop used to be about brand preference. Today, the real decision is between four specific architectures: Apple M5, Intel Panther Lake, AMD Zen 5, and the Snapdragon X2. This forces a frustrating choice. Do you stick with the guaranteed compatibility of traditional Intel and AMD chips? Or do you abandon that safety net to chase Apple-level battery life on a Windows machine? This chart maps the market split. Bottom right, Intel Panther Lake, perfect compatibility, lower efficiency. Top left, Apple M5, incredible battery, but locked to macOS. The Snapdragon X2 bypasses this compromise, landing directly in the coveted top right quadrant, providing M-series power while running Windows. A mistake here lasts years. Picking the wrong architecture means locking yourself into an ecosystem that might lack the specific driver support or native apps you need for the next half-decade. To understand the risk, you need to know how ARM on Windows actually works. It doesn't run standard Windows applications natively. It uses a translation layer to decode that legacy software on the fly. Traditional x86 chips from AMD and Intel don't have to translate anything. When you click an app, it just runs. The hardware speaks the software's native language. The reason you tolerate the translation layer is the payoff. The X2 delivers MacBook-level battery life, class-leading multi-core speeds, and massive amounts of memory for significantly less money. The downside is friction. That translation layer can cause emulation lag or hard crash when you run niche utilities or brand new games. Raw Geekbench scores don't capture these headaches. So instead of staring at benchmark numbers, we are going to map your specific daily workflow directly to the architecture that will actually handle it without crashing. Qualcomm achieved these specs by building the X2 on a 3nm TSMC process and packing up to 18 CPU cores into a single chip. This bar chart shows what 18 cores will do for you. In multi-core performance, the Snapdragon X2 extends far beyond AMD's Zen 5 and Intel's Panther Lake at similar power limits. The only processor that can beat the X2 is Apple's 18-core M5 Pro. Hitting those numbers requires about 26 watts of power at peak load. The X2 does draw slightly more power than its first-generation predecessor. Because of that higher power draw, Apple retains the crown for absolute single-core battery efficiency. An M5 MacBook will still outlast it away from the wall. But even pushing 26 watts, the X2 chip stays remarkably cool under heavy workloads. You won't hear airplane engine fans when rendering a video. If you run heavy, multi-threaded productivity software and need a Windows machine, the X2 easily wins. Apple might hold a slight edge in single-core battery life, but in the Windows space, the X2 stands alone. Graphics are handled by the new Adreno X290 integrated GPU, which clocks in at up to 1850 MHz. This delivers roughly double the graphics performance of the first-generation Snapdragon X chips. This means you can actually play demanding titles like Cyberpunk 2077 and Baldur's Gate 3 at 1080p with highly playable frame rates. The Adreno architecture still lacks modern frame generation technology, which puts a hard ceiling on how far you can push those visual settings. We are seeing real progress with emulation. Major anti-cheat systems like Epic Online Services are finally supported, meaning games like Fortnite are working flawlessly. But the translation layer still breaks down on certain AAA titles. Games like F125 crash immediately on boot, and Assassin's Creed Shadows suffers from major graphical artifacts. The X2 makes for a highly capable side-hustle gaming machine, but if gaming is your primary focus, the lingering emulation bugs make it far too risky of a purchase. The biggest risk of buying a Snapdragon laptop right now has nothing to do with the hardware. It's Qualcomm's highly confusing marketing names. The product line is broken into 3 tiers: Extreme, Elite, and Plus. Qualcomm uses the exact same Adreno X290 GPU label across both Extreme and Elite tiers, but actual clock speeds drop from 1850 MHz down to 1700 MHz on the lower tier. 2 laptops with identical-sounding graphics chips can have a hidden 15% variance in raw performance. To protect yourself, check the literal SKU codes in the fine print. You want to see X2E 94100, not the slower 88100. You have to ignore the shiny laptop stickers and dig straight into the spec sheets. Otherwise, you risk overpaying for a machine that is slower than the marketing implies. Let's map your workflow to the right architecture using this decision tree. It starts with one question. What is your primary roadblock? Let's look at the first path. Users who need perfect PC gaming. If you require day one compatibility for new releases and deep support for mods, you have to pass on the Snapdragon X2. You need the guaranteed flawless compatibility of an Intel Panther Lake or AMD Zen 5 chip. Now let's follow the second path, the road warrior who needs the absolute best battery life possible. If you prioritize single-core efficiency above all else, the market is highly competitive. You should probably buy the base Apple M5 for its raw efficiency and build quality. The only reason to pick the X2 here is if your corporate IT department mandates Windows. Ultimately, if your daily income depends on flawless legacy x86 software or pure macOS ecosystem integration, the Snapdragon X2 is simply the wrong tool for the job. But that leaves our final profile, the value-conscious power user. For this user, the Asus Zenbook A16, equipped with the X2 Elite Extreme, is the definitive answer for 2026. Looking at these spec sheets side by side, the math is undeniable. You're getting 48 gigabytes of ultra-fast memory on the Asus for just $1,599. Upgrading an Apple MacBook Pro to match that memory capacity will cost you thousands of dollars more. That is the trade-off. You accept some minor Windows on ARM software quirks in exchange for saving over $1,000 on your memory upgrades. Premium laptop pricing has historically scaled aggressively with memory. By offering this much RAM at this price point, Qualcomm is challenging the high-margin upgrade fees that have defined the market for years. For developers compiling large codebases or professionals managing heavy multitasking, the X2 provides a level of mobile Windows productivity that was previously financially inaccessible. The Snapdragon X2 has graduated from an experimental processor. For high-RAM Windows users, it is now the definitive loophole to avoid the Apple tax.